Hello and welcome to Ford's News. Tonight's top story: America under attack. Reports are flooding in about a possible attack by the North Korean military against the destroyer USS Kidd in the Sea of Japan. Reports indicate a Korean missile is traveling at 300 meters per second at an altitude of 100 meters towards the bridge of the USS Kidd. Current data from our member stations in Seoul indicate the missile is at this time approximately 1,000 meters from the ship. Wait, what's this? We're getting new information. As of now, it's being reported that the electromagnetic railgun used to neutralize these missiles mid-air has been disabled and must be manually operated. How fast does a railgun need to rotate to stay in sight of the missile and lock onto its target? We turn to Sebastian in the field to solve this problem.
Thanks, Thomas. According to the data presented, the missile is flying horizontally 100 meters from deck height at 300 meters per second towards the top of the deck of the USS Kidd. We know that at this moment, the angle between deck height and the trajectory of the missile is 5.71 degrees. We also know that the tangent of this angle is equal to the height of the missile divided by its distance from the ship. We're trying to find out how fast the gun should rotate in degrees, or d theta over dt. With these knowns, we can take the derivative of our tangent equation and use the quotient rule to get the equation d theta over dt of secant squared of theta is equal to x times dy over dt of y minus y times dx over dt of x, all over x squared. We also know that the missile is flying horizontally and will not change height. Therefore, dy over dt is equal to 0, and this part of the equation can be eliminated, which then simplifies down to d theta over dt is equal to negative y times dx over dt of x, all over x squared times secant squared of theta. Now, with our equation and our knowns, we can plug our variables in and find d theta over dt. So our equation now reads out as d theta over dt is equal to negative 1 times the quantity of 100 times negative 300 times 1,000 times cosine squared of 5.71, all over 1,000 squared. Note that the missile's rate of change is negative because it's decreasing its distance to the ship. According to our calculations, the gunner will have to rotate their railgun at 29.7 degrees per second to lock on and neutralize the target. Back to you, Thomas.
Thank you for that report, Sebastian. And we're getting news from Seoul that the missile has been destroyed. What a story. What a story. From all of us here at Ford's News, good night.